All right. We're Plastic Labs. We're a research-driven product company building at the intersection of human and machine learning. I'm Courtland Leer. My background is in education. I've spent most of my career in the classroom teaching language and philosophy. Over here on the keys is Vineeth Trost. He's a machine learning engineer, and our other co-founder, Vineeth, is over there. He's a systems engineer. So we're bringing our unique skill set to bear on eliminating the principal agent problem. So back to Econ 101, the principal agent problem basically states that humans are really messy and their interactions are really messy, especially economic ones. Whenever you engage a new service, there's all kinds of misalignments you have to account for, information asymmetries. You have to get everyone up to speed. It's laborious, it's high latency, a lot of overhead. The promise with AI applications was that they were going to solve this, but instead, what's happened is an explosion. As we've seen an explosion in AI applications, we've also seen an explosion in overhead, right? And so this problem has got to be solved. So we're building personalization infrastructure. Each AI application, each agent you interact with in your constellation of apps shouldn't have to solve the personalization and data governance issues associated with leveraging, all the abilities that LLMs and opportunities LLMs present. So instead, those applications should be focusing on their vertical specific domain and focus on outcompeting the latest foundational model at that task. So big task and build infrastructure. So of course we wrote a paper. And we think this is the first step toward getting the information that you need to get into the model so that it can act autonomously on your behalf. And we take inspiration from lots of fields: cognitive science, philosophy, psychology, machine learning, et cetera. In 1998, David Chalmers and Andy Clark wrote a seminal paper in which they argued that we are all extended systems, right? That our tools are our minds, right? That our intelligence extends into the physical world, and the philosophical differences there are negligible. So our smartphones have become appendages. The internet has become our memory. Teachers don't even make students memorize discrete facts anymore. Earlier this year, lots of researchers noted that large language models were displaying the uncanny ability to reason about what others are thinking. Basically, they had theory of mind. We see our work at the intersection of those two. How is AI going to become uniquely augmentative? How is it going to uniquely extend our minds? We think theory of mind is the key here, right? These models need to know about us. They need to reflect our psychology. They need to know us more intimately than our email or our notes or our second brain, right? They need to know our desires, our emotions, our goals, our dreams, et cetera, personal history, knowledge graph, so that they can extend our agency. The way in which, if they're able to, in order to know all that, right, they have to learn about us, right? And we take our cue from a mechanism that's well understood in how humans learn called violation of expectation. Happens from the earliest age. Developmental psychologists spend a lot of time thinking about this. Basically, what we do is we predict our environment, then we compare that with reality, and we learn from the differences. This is something that we can have large language models do as well. The way in which we get them to do that is through a paradigm that we're introducing in the paper called metacognitive prompting. Basically, we want the models to go through the same process. We want them to predict user behavior. We want them to observe what the actual behavior is and then learn from the difference or the prediction error. And so we're basically forcing the model to think about its thinking. So earlier this year, because we all have backgrounds in education, we built a popular AI tutor called Bloom, and it employs metacognitive prompting. And so it was the perfect place to run our experiment. We ran an A/B test on violation of expectation in the background. And what we found was that Bloom was able to make much higher fidelity predictions about users. When it was right, it was more right. When it was wrong, it was less wrong. Right was more frequent, wrong was less frequent, and it was synthesizing concepts across domains and conversations, and over time, really impressively. All of that has made Bloom pretty delightful to use, and since we've instituted theory of mind-inspired prompting, the numbers suggest People like it. With 10x our compute costs due to 400 daily active users and 20K unique convos just in the last 10 days. So right now, Honcho, this infrastructure product that we're building, is built into Bloom. But the next step on our roadmap is to make this a generalizable infrastructure product that any app developer can use. So that ChatGPT doesn't just write like you, much less after complex prompting. It writes as you with high fidelity. Your legal agent is you with a law degree. Your medical agent is you with a medical degree. All of your AI apps are instantly personalized, and we can offload that for the app developer. And if we're to really achieve some of even the more wacky promises of artificial intelligence, like bespoke multimodal content generated for you every second of every day, we're going to need this kind of deep psychological modeling. We're going to need to do that securely in the infrastructure product we're building. So we'd love for you to preview the paper before it goes up on archive in our Discord at Plastic Labs. And if you would like to try a Honcho-powered app, you can chat with Bloom at chat.bloombot.ai. And we're also beginning to work with design partners. So if you are a vertical-specific app developer and instant personalization sounds attractive to you, hit us up. Thanks.